Hello everyone, welcome to my YouTube channel. Today I am going to discuss about deflections, how we generally check the deflections. So generally there are two types of deflections when you start for the analysis of the structures. So you have two options to check the deflections. First one is either you can go for the creep coefficient, and the second one for the creep analysis. But it's my recommendations that you always go for the creep analysis, because creep analysis is a long term deflections. When you construct any type of structures, it is going to be for the life span of the structure, means life span of the structures is 50 years, 100 years. So we generally go for the creep analysis, that is called life long term deflection. And in the case of creep coefficients, that is a short term deflections. So here we will see that how we check the creep coefficients and how we check the creep analysis for the deflections. So firstly, apply everything's load and all, just run the analysis. Okay, we are running the analysis, just click here, it's running the analysis. Okay, we start for the running analysis. It is started for the analysis, just click here, see here, it's started. Okay, so it generally take maybe 1 minute and 1.5 minutes to complete the analysis. Generally in creep coefficients, what happen is that whatsoever is deflections you will be getting, that you have to manage to the shortening, that is used value, and then you have to multiply into 3. So that is your final deflections in the case of creep coefficients. Okay, and in creep analysis we don't multiply 3. Whatsoever you are getting the value of deflections, just manage the used value, that is called axial shortening. That is the your deflections that is coming on your structures, and you have to compare that. In RCC structures, generally the deflections limit is spanned by 350 or 20 mm, whichever is less, that is the value. So you have to compare that. Whatsoever you will be getting the deflection value, that value should be less than that value spanned by 350 or 20 mm, then your structure is safe behalf of the deflections. Okay, so let us see. You can see that it's going to be completed. So we'll see that here. Now first we'll see that creep coefficients, how we check the deflection in creep coefficients. Okay, then after we see the creep analysis. Okay, so just 17% completed, 40%. So it generally takes time, because it generally calculate every point of the analysis, and then after it generally give the results. So it takes generally times. Okay, so after that what happen is that after completing, how we'll see the deflection of the creep coefficients. So let us see. It generally takes time. Okay, don't worry, because it is the process for the deflections and all, for the analysis process, it generally take the time. So you will have to keep patience for that. Then after you will get the result. See, it's completed. Okay, so this is the control line. So here we generally see the deflections. So you can see that here deflection is getting in meter. So what happens is that just you click here and just go for the mm. Okay, so now you can see that your deflection here, overall deflection is getting how much? 20.32 mm. Where it is getting? So see, this is x, this is y, and this is z. So in the case of ETABS, the vertical is z only, but in the case of Stat Pro, vertical is y. So here you have to see that at which level, 16638.4 mm, the maximum deflection is getting 20.32. So you have to see here. See, you have to go here. Now you are in which floor? fourth floor 13088, but you have to see 16638. So what you will have to do, just go to the plan, sorry, go to apply and OK. See here 16638.4, this floor you came where deflection is getting 20.32. Now you have to check that where deflection is getting this much. So here the process is that 20.32, here you have to see that in which color. So it will be in between this color. So in between this color the deflection is 20.32 mm is getting. So you have to see this color. So just click here. See here how much 20 point UZ, you have to see the UZ value, that is the deflection. Okay, so UZ is 20.32. How much? See 20.32 means at this point deflection is getting 20.32. Okay, now you have to see that either it is only slab or here any beam. Firstly you have to check deflection is getting on beam or slab, because if deflection is getting on slab, so what you will have to do, near about 4 column you have to take. Suppose this is the deflection here, this is 20.327 mm deflection is getting. Suppose it is getting on slab only, so around that you have to see that where is the column. So just go here and see this here column, this column, this column and this column. Okay, so all these column shortening value, axial shortening value you have to see, this axial shortening value you have to see, axial shortening value here you have to see, and axial shortening value here you have to see, and minimum value of axial shortening means UZ value. So whatsoever UZ value you will be getting, you have to manage that deflections and multiply into 3. So this is the maximum deflections you are getting on these structures. Then you have to compare span by 350 or 20 mm. You will have to see that value should be greater than this value, then after your structure is safe. Okay, so here just go again, just go to show deformed shape and go to combo, click here dead load, live load. Okay, and now just apply and OK. So here the deflection is getting how much? Maximum deflection 20.182 you are checking. Okay, so in this case the maximum deflection 20.182 is getting on this point, but here you can see that here is a beam. See here means on beam deflection is getting 20.82. so what happens is that you have to see the axial shortening value of this beam here, UZ value, or here UZ value. Whatsoever value will be less, that you have to take, and 20.82 minus that UZ value. So that is the final deflection multiplied by 3. Okay, so just again go to show deformed shape, and here you have to see combo and dead load and live load. Due to the gravity load we generally check the deflections in creep coefficient. Okay, so here the value is 25.182. okay, and here how much it is getting? 20.21, and at this corner 13.37. so which one is less? This value is less at this point, 13.37. so see, this is the axial shortening. You are saying that UZ value, UZ is the axial shortening value. Okay, so maximum deflection is 25.18 minus this 13.37. okay, so 25 minus 13 approx is getting 12 mm. So 12 multiplied by 3 means 36 mm deflections, maximum deflection is getting on this beam. Now you have to see that either this deflection is safe or not, because you know that in the case of RCC the maximum deflection is span by 350 or 20 mm, whichever is less. So now just go to the draw and draw dimension line and just check the distance, this one up to here. This is how much getting? 6 meter approx, okay, because 6091 mm the approx 6 meter. So span by 350 means 6091 divided by 350, whatsoever value will be getting. So just I am calculating, okay, here to better understanding. Just go to the calculator. Okay, here see, here is how much? 6091. Okay, so just go to 6091 divided by 350, how much getting? 17.40 and or 20 mm. So whichever is less, that is the maximum deflection allowed on these structures. Okay, so only max deflection should be 17.40 mm only. And how much we are getting? We are getting 25.18 minus this is 13, means how much getting? 25.18. So just again go to calculator. 25.182 minus how much here getting? 13.372. 13.372. 18.81 multiply by 3. So means 35.43 mm deflection is getting, but how much allow? Only 17 mm. So what you have to do? You have to increase the depth of the beam, or neither you have to means like you have to add one more beam like that. Okay, we'll see that what happen. So now again just go to undeformed shape, click here, just okay. So it has been undeformed. Now you have to see that how much thickness of this. Just click here. What is the size of this beam? Just click. How much? 9 inch into 12 inch. You have to increase the depth of the beam. Okay, firstly. So just go to the show modeler here. Now just go to the property and frame sections. So here instead of 9 inch into 18 inch, we are taking 9 inch into 24 inch. Okay, see here 9 inch into 24 inch. Here see, here its column properties is created, so it's better you have to go for the beam properties only. So 9 inch into 18 inch here. Okay, so again you have to run. After completing this, again you run, you have to run the analysis again to check that either deflection is under control or not. So this is the process to check the deflections in terms of creep coefficients. So firstly we see that creep coefficients, how our structures is getting safe or not, because we have increased the depth of that beam. We'll see. Okay, just wait. After completing this, we'll go for the creep analysis for the long term deflections. In that also we'll have to check the deflections. So suppose you are taking the creep coefficient, then there is no need to check the creep analysis. And suppose you are taking the creep analysis for the long term deflections, then there is no need to go for the creep coefficients. At a moment in structures only you can go for the either creep coefficients or creep analysis. Okay, So it's going to be completed. We'll see that how much deflection is getting after increasing the depth of the beam and all. There are different options. You can increase the depth of the beam, you can increase the grade of the concrete and all to control the deflection, or you can add one more beam if they are needed, so it will be also better for that. Okay, so see how much getting. Now you have to go for here, show deformed shape, combo and dead load, live load, and just apply. And here we'll have to see it is getting 26.62 at this level only. I think not this level. I think, see, now it's getting here 26.62. see here, means this portion already saved, but this portion is not saved. 26.62, and here beam or not, I don't know that. We'll see. Just undeformed. Yeah, here there is no beam. So what happen is that, see, just go to again and apply and OK. Now see here 26.62. okay, now there are 4 column here. So first column value is 4.97, second is 6.117, third one is 6.01, and fourth one is how much? 4.70. So whichever is less used value, action shortening value, you have to take. So just 26.62. So just go to calculator and see 26.62. sorry 26.62 minus how much? Here value is 4.97 axial shortening used value. Here it is 6.117, and here column 6.01, and here how much? 4.70. so less one is 4.70 or 4.97. so this is less, so 4.70 minus 4.70, how much? 21.92 into 3. See, deflection is 65 mm, but it's not allowed because deflection is only up to here. You have to take the distance, divide by 350 only, means anyhow it should be less than 20 mm. Deflection is getting too much. So what happens is that again you will have to do one thing, that here we have to add one more beam here. Okay, and then after you have to divide this slab and you have to create one more beam here, and then again same process. So automatically it will be getting safe. So I just my motive that how we check the deflection in creep coefficient. I thought you understood what is the process for that. Now how we'll check the creep analysis for the deflection. This is for the creep coefficients we have seen. Now creep analysis. Okay, so just undeform the structures. Now firstly you have to go for the define, and here you have to go for the auto construction sequence case. This is case is active, auto, just click OK. Now again go to define, go to load cases, and here just click and go to add copy of case, and here you have to write creep analysis. Okay, so creep analysis. Okay, and here see how much floor it is. So this is, you will have to see again, just go again back and see, go to edit storage and git system, and here you have to see that how much ground floor, first floor, second floor, third floor, fourth floor and fifth floor, up to fifth floor. So just go to define, go to load cases, and here go to auto sequence, add copy of case, and here creep analysis, means long term deflections we are going to check. Creep analysis, and here first write ground floor, and number of duration days is 21 days. What is the meaning of this? The meaning of this, that suppose this is ground floor, this is first floor. 21 days means ground floor shuttering will be completed after 21 days. So this value generally given by the project engineer. The project engineer who will work on the site, so this value they generally provide, means ground floor how many days it will be completed. So normally for the analysis we generally take the 21 days normally, okay, but exact value project engineer generally give to the structural engineer, that first floor or ground floor will be completed within 21 days, then after first floor also 21 days, like that. Understood? So here 21 days, first floor also 21 days, second floor also 21 days, then third floor 21 days, fourth floor, so fourth floor FF1, because same value it will not take, because FF here, so fourth floor also will take, neither you just write fourth, it will be better to understand, fourth floor, okay. So this will also 21 days, and here fifth floor is 21 days, okay. After that you have to go for the after occupancy, matlab after completed. So we generally take the 365 days, means after 1 years. So here you have to write after occupancy. How many days? Sorry, here after occupancy. After occupancy it will be 365 days, 1 year we generally take, okay. Next, that after 10 years, means we have either you can go for the up to 50 years or 100 years. So here we will take 50 years only. So after 10 years, 10 years how much? 3650 automatic duration days, then again it will be 20 years, it will be again 3650, then sorry it will be 20 years, and it will be 30 years, so 30 years also same, and here 40 years, so 40 years same, and here it will be 50 years, okay. Now completed. Now just click here, material properties are time dependent, just click here and go to stage operations, click here, and now here you have to come down here, first floor, like see ground floor, okay, and here you have to take add structures, story, base, add structure, story, ground floor how many days? It will be 21 days, and here load objects if added you have to go group all, load pattern, dead load, scale factor you have to take 1, okay. Then go to first floor. In first floor it will be take 21 days, again it will be same. Second floor also it will be 21 days, third floor 21 days, fourth floor also it will be 21 days, fifth floor it will be 21 days, and after occupancy only it will be load objects, okay, group all, and here we go for the live load, means we generally assume that after occupancy only 25% live load will be there, so we generally check 0.25 only, okay, for that. And then after nothing will be there, it should be blank, okay, because 30 years, 40 years, 50 years there is no any deflection at all, okay, we generally take. And again you have to check one by one, 30 years, 20, 10, Here load objects group all, load pattern live 0.25 okay, and here it is okay, okay, third floor, second, fifth base, okay. Now just click ok, and here also click ok, and here also click ok. Now you have to go for the define material properties, and whatsoever grade of the concrete you are going to use. Suppose you are going to use M30 grade of concrete. So first see here there are two types of grade of concrete, M30 or M20. So which one is going to use, either both or only M30? So you have to check here. Just go to the beam, click here and modify which grade you generally use. It will be shown M20 here you use, okay. Like here also I think M20, here also M20, okay. So here also I think, because I don't know that all beam we have been used or only some, so you have to check, cross check is very necessary. Now you have to go for 9 inch 24 inch. So here also M20, okay. Now 9 inch 30 inch. So here M20, okay. Now again M20, okay. So I think in beam we generally use only M20 grade of concrete, M20, okay. So now you check the column also. So in column also M20 use. So I think we don't use M30 grade of concrete. So you have to go for only M20. So just we checked. Now go to the define material properties, and here you have to take M20, go to modify or show material. Just click here and go to time dependent properties, and here time dependence considered for, just click here compressive strength and stiffness we are taking creep analysis, and we are taking shrinkage, okay. And this is the code SCEB FIP90 is the code for here, okay. Now just go to show plot, click here, and here you have to go for the creep coefficient. For the notional size is 300 mm and age at loading is 21 days, and it will be 0 to 10,000 days like that, okay. Just click here okay, just here also just click okay, okay, and here also okay. And now just run the analysis, okay. It will take time because in creep analysis it generally take some more time to complete the analysis. So this is the process for the creep analysis. Before we have seen that how we check the deflection in creep coefficients. Means in creep coefficients only you have to multiply in 3, but in creep analysis there is no need to multiply into 3. Whatsoever deflections value is getting, just manage to the axial shortening UZ value, and then you have to compare span by 350 or 20 mm. Whatsoever value is less, then you have to compare for both, either it is under limit or not. Accordingly we have to decide. So it's mostly it's going to be completed 13%, 17%. So it just take time, okay, some more time. So you have to keep patience for that. But it is very important things. But being a structural manager, it's my recommendations that always you prefer for the creep analysis, because it is very good for the structural safety points of view, because in creep analysis we generally check the long term deflections, and structure is also is going to be for the long term we generally construct. So but should have knowledge about both, how we check the creep coefficients, how we check the creep analysis and all. There are different things. And so 50% is going completed. So I hope you understand that how we generally check the creep coefficients, and what is the process for the creep analysis. See, in creep analysis, whatsoever I have put the value, so if is there, while putting the value, if there is any mistakes, what happens is that, whatsoever analysis is here, see, 75% completed, 83% completed, it will not run. Only 3%, 4%, you will live 1 days, okay, but it will not completed 100%, because if you did the mistakes in putting the value in creep analysis. If you don't believe, just once you try only, okay, just you put wrong value and all there, and just you see, analysis will not be completed. So this is the very you can see that ETAPS generally give this type of thing to identify that either you have gone in very good way or wrong way. So this is the process, okay. So almost it's completed. Now we'll see the creep analysis deflections. Yes, just only 1 minute wait. I think it's going to be completed. Yes, okay. Yes, okay, just completed. Now just go to the show deformed shape, go to the combo, and here dead load, live load, dead load and live load, and apply, and you have to see the deflections, how much deflections is getting. See, 26.62 mm deflection is getting in creep analysis, okay. We are getting, so this is 1638.4, so how much, 26.62, and same here, see here, how much, 4.97, this is 4.70, this is 6.01, and here this is 6.117, so 26.62. So just go to the calculator, and here 26.62, so 26.62 minus axial shortening value, because here there is no any beam, only slab, deflection is getting on the slab. So near slab whatsoever column is there, you have to choose that one, okay, and minimum one axial shortening value you have to consider. So here minimum how much, 4.97, so minus 4.97, so maximum deflection is 21.65 mm for this. And how much allow, just go to the draw dimensions line, and here you have to see the how much value, this is 6096 span, so span by 350. Again go to the calculator, 6091 span divided by 350. See, 17.40 mm, our deflection is getting how much, 21 mm, means now also 4 mm deflection is getting more, because here no need to multiply into 3, because in creep analysis only whatsoever deflection is getting, just minus axial shortening, that is the value of the final deflections. But here deflection allow is 17.40 mm only, but we are getting how much, that is approx 21 mm. So means again you have to provide here some beam to reduce their deflection. So this is only the process to check the deflections in creep coefficients or creep analysis. I hope you understand what is creep analysis and what is creep coefficients. Creep coefficients means you can say that it is a short term deflections, but in creep analysis it is a long term deflections. So thank you so much. If you like my channel, kindly share. If you have any doubts, kindly message me. I will try to reply. Thank you so much. Okay, thank you.